Okay, hello everyone. I welcomes to all in our lecture series on error function. In our last two classes, we have been discussed this topic and this topic. In this class, we are going to discuss integration of error function and complementary error function. In our lecture number 3. In lecture number 1, we discussed this one, definition and characteristics of error function and complementary error function. In lecture number 2, we discussed the derivative of error function and complementary error function with corresponding questions. In this class, we are going to discuss integration of error function and complementary error function. Okay, so let us start. So in this class we are going to discuss first the integration of error function, then we are going to go for integration of complementary error function. Okay, first we are going to discuss integration of error function. Here I am writing find the integration of error function, that is ERFX. That means we have to evaluate limit 0 to t error function. Suppose ax is there, dx. What will be the value? Okay, so here solution starts. Here we have to evaluate 0 to t error function ax dx. To evaluate this integral, we have to recall the integration by parts. May you know about integration by parts? I am going to write the general expression or general form of the integration by parts. That if we have two functions u and v, like this, u and v integration with respect to x, and u is your first function, v is your second function, then what we have to do? First function integration of second function, okay, then minus integration of derivative of first function du by dx, then integration of second function, that means v, integration of second function, then whole integration. This is the procedure of integration by parts. So here we have this integral, right? Or we can write this integration as 0 to t ERFAX into 1 dx. Here we are going to consider this function is your first function, that is your u, and this one as your second function v. Okay, now we are going to apply the by parts on this integral. So what we can get? Error function ax is your first function, then integration of 1 with respect to dx, okay, then minus 0 to t differentiation with respect to x of first function, that means error function ax, okay, then integration of second function, that is your 1 dx, and whole integration with respect to dx. Okay, now integration of 1 with respect to x is your x. So here it will be error function of ax, integration of 1 with respect to x is your x, lower limit is 0 to t, minus here differentiation of error function ax value. Directly we are going to substitute in our previous class that we evaluated, that one, d by dx of error function of ax equal to 2a by root pi into e to the power a square x square, e to the minus a square x square, that we are going to substitute over here directly. So 0 to t limits are there. D by dx of error function of ax is nothing but your last class we evaluated 2a by root pi into e to the power minus a square x square into here integration of 1 with respect to x is nothing but x and dx. Okay. Okay, now here substitute upper limit and lower limit. So this will be error function of at into t minus lower limit is your 0, error function of a is into 0 into 0. Okay, then minus here 2a by root pi constant taken outside of this integration 0 to t e to the power minus a square x square into x dx. Okay. Okay, this term will be 0 because 0 into this much means 0. So we found this much value, that is your t into, first I'm going to write t into erf at, t into erf error function of at minus this integral here as such I written. Now we are going to evaluate this integration e to the 0 to t e to the power a square x square into x dx. Here you can omit the steps, I written 2 times here. So to evaluate this integration we consider put a square x square equal to p. So that implies a square is the constant, a square 2 dx 2x dx equal to dp, right? That implies x dx will be how much? dp by 2a square. Now we are going to consider the new limits, which is important, most important here. For x equal to 0, because lower limit is your 0, that implies p equal to how much? Here if I'm going to put 0 over here, p also 0. For x equal to t, because higher limit is your t, if I'm going to substitute t over here, then upper limit will be a square t square. Okay, now the uh, above integral or above equation written as t into erf at, error function of at written as such, minus 2a by root pi. Here the integration limits, the new limits are 0 to a square t square e to the power minus p, because we considered as a square x square is your p, e to the power minus p into x dx, x dx value is your dp by 2a square. Okay. Okay, so t into erf at, here 2 got cancelled, 1a got cancelled, so the remaining denominator is your root pi into a. So just write a into root pi, integration limits 0 to a square t square e to the power minus p dp. Okay, now t into error function of a t written as such, minus 1 by a root pi is there here, e to the power minus p dp. That means the integration will be how much? Minus e to the power minus p. The integration limits is your 0 to a square t square, right? We have to just substitute the limits. T into erf error function of at minus 1 by a root pi, here minus minus plus, you just write minus minus plus, then upper limit is your a square t square, so this will be e to the power minus a square t square, then minus lower limit is your 0, so e to the power 0. So finally we get the answer of integration of, so that implies integration of 0 to t error function of ax, error function of here, error function of ax dx equal to t into error function of at plus 1 by a root pi whole into e to the power minus a square t square. Here e to the power 0 is your minus 1. So this will be this is your answer. Okay. Now we are going to go for integration of complementary error function. Okay. Next we are going to find out the integration of, next question you can say this one, integration of complementary error function of ax dx. Limits 0 to t will be how much? Same procedure we have to follow. Okay, so let us start here. Already how to do the by parts already we discussed, and here this function will be considered as your first function, and this one here multiplied with 1 will be considered as your second function. So by using by parts, the above integral will be written as the above integral will be what here, that implies 0 to t complementary error function of ax dx is equal to, first function is your complementary error function ax, second function is your 1 dx, limits 0 to t. Okay, then minus integration 0 to t derivative with respect to x of complementary error function, that means first function error function, complementary error function of ax derivative, then integration of second function whole integration with respect to x. Okay, okay, so that implies 0 to t complementary error function, integration of complementary error function 0 to t, here integration of 1 with respect to x is your x. So here this will be complementary error function of ax into x, the limits are 0 to t, minus derivative of complementary error function. Already we discussed in our last class this one. Here I given that you have to do by yourself. Here derivative of error function is your 2a by root pi e to the power minus a square x square. Derivative with respect to x of error function of ax will be minus 2a by root pi e to the power a square minus x square. Here if I am going to compare with this error function and its corresponding complementary error function of ax, then we can found only minus sign is the difference. Okay, so if you done, you can found this answer. Now we are going to use this answer for our integration directly. Minus 2a by root pi, here 0 to t integration limits is there, minus 2a by root pi into e to the power minus a square x square, and here integration of 1 with respect to x is your x dx. Okay, okay, so is equal to, here I'm going to substitute the upper limit then lower limit, error function complementary error function at into t upper limit minus complementary error function a0, that means 0 into 0, here minus 2a by root pi taken outside of this integration remaining written as such: e to the power minus a square x square into x dx. Same procedure we have to consider what we consider here. Same procedure. That means here, if I'm going to consider the integration of this much, how much we found? We found this one, this much. Okay, directly I can write, but here you just do the steps. Error function of complementary error function of at into t, because this part will be 0, then plus 2a by root pi 0 to t e to the minus a square x square into x dx. Now to evaluate this integration, same procedure we have to consider. Put a square x square equal to p, that implies x dx equal to dp by 2a square. If we are going to consider the limits, then for x equal to 0, that implies p also will be equal to 0. For x equal to t, that implies p will be a square t square. Same procedure. So the above equation here, a complementary error function of at into t, I can write t into complementary error function at, okay, plus 2a by root pi. Same procedure, 0 to new limit will be a square t square into e to the power minus p into x dx. Instead of x dx, it will be dp by 2a square. Okay, so this will be t into complementary error function at plus here 2 got cancel, 1 a got cancel, and we found a 1 by a root pi, and integration of e to the minus p dp is nothing but minus of e to the power minus p 0 to a square t square is equal to t into complementary error function at. Here minus, this will be minus 1 by a root pi. By substituting the upper limit, e to the minus a square t square, lower limit is your 0, e to the 0. So finally we found that implies integration from 0 to t of complementary error function ax with respect to x, we found this much: t into complementary error function of at minus 1 by a root over of pi into e to the power minus a square t square minus 1. So this is your answer. Now if I am going to compare uh, integration of complementary error function, the value we found how much? t into complementary error function of at minus 1 by a root pi e to the minus a square t square minus 1 with error function ax dx integration. Then both are same, but here this is the plus sign, here this is the minus sign. Same terms. Here t into error function of at plus 1 by a root pi e to the power minus a square t square minus 1, and here same t into here the corresponding function, here complementary error function of at minus 1 by a root pi e to the minus a square t square minus 1. Okay, so this is all about integration of error function and complementary error function. Okay, so here I am going to stop this lecture. In our next lecture we are going to discuss some miscellaneous questions on error function and complementary error function. Okay, so thank you so much for watching this video. Thank you.